Hi, everyone. I'm Justin from Toolpath, and with me today is Devin Bodony from Lichen Precision. And he has very graciously agreed to let me pretend I know what I'm talking about with automation today. Uh, so, before we dive into our debate about whether or not you should buy a new spindle or a robot or pallet system, some kind of automation, why
Both.
don't you just briefly introduce yourself to our audience?
Yeah, I'm Devin Bodony. I run a company, a little job shop outside of Seattle called Lichen Precision. We're a six-person team here, and we do a little bit of production work and then a lot of high mix prototyping and tooling in aerospace and tech. And that's the quick intro.
And what kind of machines do you have in the shop?
We have a mix of Brother and Takasawa. We have a Brother R450 twin pallet machine with fourth axis trunnions on both sides of the table. We have an S700 with a trunnion, fourth axis trunnion, and a M300 five axis mill turn. And then the Takasawas are a TCN 2100, which is the basic two axis turning center. And then we just got a TCY 200II, which is a subspindle y-axis milling lathe. And then on the inspection side, we have a CMM and OC and height gauges and all that kind of stuff.
If you want to know a much better history of Devin's frankly epic backstory, go check out episodes 181 and 269 of Within Tolerance. Highly encourage those. On your recent episode 269 of Within Tolerance, I heard you mention very briefly that you thought you could use another spindle before you bought an automation system. And that was in the context of noting that your M300 was like your most profitable machine.
Yeah.
And you just didn't feel ready for automation, but you felt like a new spindle could help, I guess. Well, tell me, walk me through the start of that logic.
Yeah. And it's kind of a question of like automation or second spindle or both. Ideally both. It's just how do we afford that slash not so much afford it, honestly. How do we like ramp up into being able to utilize that capacity? And by the numbers, as I'm sure you'll lay out for us very eloquently, the automation is a better option in terms of like total cycle time that it buys you moving forward. However, when I look at our work mix, I get very anxious about the ability to capitalize on that automation. And there's a there's a couple, I mean, there's several key pieces there, but one of the largest ones is just like we're doing a lot of work right now that's kind of at the edge of our skill level
Mm-hmm.
and at the edge of our machine's ability to pull off, both from
Mm-hmm.
like a part size, material type, and tolerance complexity standpoint. And so what I'm concerned with just adding automation is kind of the scenario where let's say you land a job that has 7 part numbers, and of those 7, well, let's just say all 7 have to run across that M300 because of the type of work it is. And of those, maybe the first one you feel like you could automate effectively, and then 2 through 5, let's say you don't think you can, and then the last 2 are sure, like easy gimmies. In that scenario, the automation solution effectively, I think in our shop right now, with our level of skill and our level of technology, I think it would sit idle for that middle sequence. And so the reason that I imagine pushing towards a second spindle is in that scenario, we have the option to kind of like multi-thread that work to distribute it across more work centers. Um, and where I don't have good information right now is like, in part, just because we haven't done it, is how much of that work could we actually automate with a pallet pool and a single spindle? And there's like a million different scenarios you could run here. One is just like, well, just rough it at night and come back and do the hard stuff during the day. Or resequence your stuff so that you're, running an easy part every night and hard part in the day. But my experience in the shop in general has been the more sort of contingencies or constraints you put on the system, the harder it is to capitalize on. And so the idea of having multiple spindles plus automation feels like a warm blanket, like it's comfortable in the sense that I'm like, well, when things are going this way, we can just, run it the way we know across multiple machines. When things, when the script flips, we can automate it all and whatnot. So that's kind of like, that's the basic background. And then I guess the other part, which you and I have talked about offline a bit, is that a major compounding factor here is just the tool capacity of the brother machines. And in high mix work, the options, right, are like standardize your tool library or get really good at changing over tools. And for the work we've done, we have found that a very standardized library in the machine is not really practical. We have to break the rules so often that it's basically just like not a rule.
As a side note, but important, you're on an amazing podcast called Incremental that I take a lot of inspiration from.
Oh, thanks.
And so in the sort of spirit of lean and incremental improvement, I'm going to constrain our discussion a little bit and break it down. So for the sake of discussion, let's assume that you had to choose between a robot or a second spindle, that you couldn't just buy both. Because obviously, like if you could buy both, then why wouldn't you buy both?
Yeah.
We can graduate to the combined solution later. And then beyond that, let's sort of just dig into some of the details about like why automation feels so scary. Because, and I should say one more thing. For the sake of this discussion, I am all in on trying to convince you to go with automation first. But in reality, I know that the decision is not that clear cut. But I'm going to play the antagonist here.
Yeah, absolutely.
Okay, so let's start with some of the like most basic math about robot versus spindle, right? So, and also let's just take for our listening audience, like if you're considering between part loading or pallet loading, I'm just going to take that off the table. Automation, somehow magically, if you want part loading, that'll work. If you want pallet loading, that'll work. Like we're just talking about getting material in and out of the machine through some magic process, right?
It's like the YouTube video where the guy just throws the brick into the lathe and then it comes out as a finished part.
Yeah. I just snap my fingers and the part's loaded in the vise perfectly every time, somehow magic.
Yep.
Okay, so like the most basic math is that a robot, in theory, roughly at its maximum capacity, will triple the output of your existing spindle, or it'll go from 1 shift to 3 shifts. So it's what is that? Yeah, it's 150% increase.
Yeah.
Versus a second spindle, if you only have 1 shift, at its absolute theoretical best, could double the output of your shop.
Yeah.
Now, you've already mentioned some of the mitigating factors there, but just on that basis alone, it seems like the robot, like at the very start, the automation is the better bet. The reality, though, is that none of those systems ever reach their full capacity, right?
Sure, yeah.
So then for me, the secondary one, and this is the first point I really want to press on, an extra spindle increases, like to actually get more throughput from your shop with an extra spindle, it increases the amount of work that you or your employees have to do like at one time.
Sure.
You somehow have to either be more efficient, or it turns out you have a lot of downtime, waiting for parts that you can utilize. Versus an automation system, like it's a force multiplier. It works while you're not there.
Yeah. The one caveat I would say is that the majority of our work is not loading parts. So the majority of the work that we do is programming and proof out and setup. And that would be the same for both.
You don't have to, like, once you get prove out, you don't make like 3 more of something and there's like 5 hours of machining where somebody has to be there to load the machine.
Yeah. They do, but that's not like that's like someone's 10%, right? Where they can do that. So the way we work in our shop typically is it's a little odd because we're a small shop, but we in some ways are structured like a bigger shop in
Okay.
terms of our organization. So typically, and people flex roles for sure, but typically there's someone who programs the work that gets handed off to someone on the shop floor who will prep the job. So like build tools, cut stock, assemble work holding. That gets often handed off to someone who sets up the job and proofs it out. And then typically, and this is not always the same person in the shop. It varies based on kind of whose workload is what. But then typically there's one person in the shop who's just kind of like tending machines and keeping them going.
Mm.
So the difference for that person of tending 5 machines or 6 machines versus 5 machines is not significant. So I would say that the robot buys us a lot more theoretical runtime, but I'm not sure it changes our workload on the tending side specifically. Like
Because you already have human automation essentially.
Yeah, kind of. I mean, it's limited in hours. That's the big thing. But in terms of like the bottleneck workload in the shop, it would still go up. The bottleneck workload being programming and setup and
Okay.
because we still would have, that's a process that we would still have to do manually at this point.
I mean, I can't imagine like automation doesn't solve that, right?
Yeah.
I mean, maybe CAM automation solves part of that in the future, but we're setting that aside.
Yeah. Well, I think like if you're graduating beyond sort of the commodity brother machine tool world into a machine that has a tool matrix and you keep a ton of work holding built in the pallet pool, that does alleviate a significant amount of that workload. You still have programming, but now your tools are pre-prepped in the machine, presumably. And often I would imagine the bulk of your work holding is already pre-prepped. So then it's just about arriving with material and programs that are good to go.
Okay. All right. So this is actually pretty interesting because that's not, even though we've already talked about this, that's not where I thought you would go with that. Offline, you and I have had a number of discussions about fancy ways to like optimize tools in your machine.
Yeah.
And yeah, the Speedios have like 28 tools now, I think is the limit here.
Yeah. Well, there's the one with 100 and there's rumors of some other with like intermediate, but
yeah. And absolutely. Yeah, if you can't keep enough tools in the machine to run. So if I'm understanding correctly, let's pretend programming was not a bottleneck. You had your programs ready to go, and you had a bunch of vices, your 5 or 6 different standard work holdings kind of ready to go.
Yeah.
Then you feel like you could pretty confidently program a part, have somebody chuck a piece of stock in the work holding, or maybe it's already there, and you would just send it to the pallet and run a prove out confidently.
Not with our current level of skill. Yeah.
Okay.
Yeah. But in theory, that's possible.
In theory, that's possible.
Yeah.
Okay. So, if that's the case, if it sounds like, cause within tolerance, you talked about buying another M300, and we have a Speedio here at the shop. I really enjoy running it.
Yeah.
But if you really feel like your bottleneck is tooling, why would you not consider a machine with a bigger magazine?
I do consider a machine with a bigger magazine. Part of it is being cheap. The other, well, I mean, that's more of a joke. The real reason is, well, there's a few different reasons. One is the bulk. I just went through and did a little tally here before we got on the call of like our biggest customer the last like 4 months, like how many of those parts were mill turn, how many of them were strictly milling, and how many of them were strictly turning. And of them, part numbers 45 were mill turn, 25 were turning, and 20 were milling. And so you kind of get a sense of our mix. And
all of those went through the M300?
No, the straight turning, depending on kind of what our workload went on any of the machines which have turning. So that would be either Takasawa or the M300. Sometimes even if a part is just straight turning, if it's just like two of them, we'll run it on the M300 because the setups are so much faster. And the mill turn, the bulk of those went across the M300. A handful went across the new Takasawa that has milling. And then the strict mill tool paths, some of them probably did go across the M300 as well. Again, just because we sort of try and prioritize that as a high mix machine and not clog it with long runtimes. So our other mills will have longer runtime jobs stuck on them. Where was I going with that? Oh, so where I was going with that is that like a high percentage of the parts that we make require turning. Even if it's a small thing, like we get we get a not insignificant number of parts that are mill parts, except they'll have like a concentric surface finish call out, which you could do on a mill, but it gets pretty weird. It's not super flexible. And then, so if I start looking at the solutions, like we'll just talk about Hermlock, because that's one of the leaders. If you take any of their machines with a pallet pool and get the version with turning, you're talking about like $1.5 million, potentially more machine. And at that price, we could have like, I don't know, 6 M300s or something. It's not the same machine, and there's additional costs, which I'm sure we'll get to, in being able to get an M300 to the level of like being able to run work automated. But part of it is just that cost calculation where it's kind of like the cost benefit, at least for the parts we're doing right now, I don't necessarily see as being there. The other thing, which is not insignificant in our shop, is we put a lot of work into standardization of tooling, and the idea of adding a new taper to the shop is a bit overwhelming. And also adding a new control to the shop is not an insignificant thing. Even just like bringing on this Takasawa, I was like, oh, it's the same brand. The control will be almost the same. It's just like basic Fanuc. And it has been there's some mitigating factors, like the machine is quirky. But it has been a bit of a nightmare to get it up to speed, and imagining going to like an entirely different platform with a different taper, et cetera, is kind of like, that's a big undertaking. Like, I think we would have to kind of set aside all other goals in the shop for a while and be like, this is our number one focus for like, we're going to keep things rolling, but like we will pause any other kind of improvement projects in the shop for a bit, because this is going to be an all hands on deck sort of endeavor.
That's very interesting. I hadn't really thought about it from that perspective at all. I'm very, like, I use 2 controls daily, and to be honest, I'm not comfortable on a pure Fanuc or a Haas control, but I would expect like a day or 2 of playing with one and I'd be fine. Maybe that's a little arrogant of me. I'm sure there's more to it than that, but personally, hopping from control to control doesn't scare me, like, fundamentally. But when you have a shop full of people and like a very detailed and dialed process, I'm going to call it inertia. I can see that inertia being like a real factor that you have to consider.
Yeah, and honestly, like the individual interacting with the control, that's like one thing. The bigger issue is more getting your pipeline from 3D model to machine well dialed to the point where like your post is perfect. You know, your machine receives the code perfectly. You have everything in CAM set up where, you know, your templates pull the right post, everything flows downstream without hiccups. That's more where we've seen the issues.
Right.
Like, things on the control itself are fairly easy to tackle. Like, we have a whiteboard at the machine. When something weird comes up, we write it on there, like, you know, at startup, do this code kind of a thing. Or we have cheat sheets in our little SOPs document that's like, here's all the weird stuff with the TCY. If you run into this issue, do this kind of a thing. But also, I will say that like the spin up for that machine has been generating that cheat sheet and finding where the mistakes are and finding how to solve them when they do happen. So that's kind of that's the part that has me wary, and in addition to the cost, right? Like taking on the cost of $1.5 million machine is no joke. You have to have serious business inertia in order to make that function.
I was going to suggest that there could be lower cost options, but I had forgotten about the reliance on mill turn and going to like a multi machine where like you turn features are done on one machine and then transfer the milling to another. That's probably a bridge too far.
Yeah, that is a scenario that's crossed my mind, especially if we stayed in the brother universe, would be like buy the U500 with 100 tools and have automation between the two and like run your mill work in the U500 or the bulk of it, and like keep all like, because a lot of this stuff is like needing drills and taps for a full range of metric and standard threads, and then some extended reach tools that are not something you're going to keep in a limited tool capacity machine every day. And if that stuff could kind of live in the U500, and you could be like, okay, we have op one that runs in the U500, we transfer it to the M300 and do the turning and whatever else we can do with its standard tool library. I could see that being a scenario, but again, we're branching into a level of complexity where it's like automation really shines when you can just like do everything in the one machine and it's done.
Mm-hmm.
So
yeah. I would have also encouraged you to look at like a MX330 with a PC10 pallet pull. They're surprisingly price competitive right now. But it's not turning. So
no, they do have a turning option, which I have not gotten a price on.
I mean, like the dollar to yen trade has made that end machine competitive. And I think they're specifically trying to make the 330 platform very price competitive. So
yeah.
In the spirit of this discussion, I would encourage you to get a quote on that. Because a 10 pallet pool, like factory integrated like that would be, very good. We still have the 40 taker problem there, but
yeah.
Okay. Let me dig in a little bit more here in my role as antagonist, because look, I like making $1 million investment kind of, no matter how you scratch it, maybe you could get it to around 600 grand, 700 grand with like the 330.
Oh yeah.
But you're still in that ballpark. Automation, like fundamentally, when I think about it, it's how do I scale my business, right?
Mm-hmm.
And how much money am I willing to spend right now to unlock that level of scaling? So like adding another machine, coming back to that original math, like adding another machine would allow you to like leverage some opportunities for efficiency in the shop and give you like a little bit more growth, but it wouldn't fundamentally like give you that leg up to doing less work to make more money,
Sure.
being in the office less. And so as a mental exercise, and I really do deeply understand like all the issues you've raised so far, inertia, tapers, processes, all of that. But some of that could just be solved by paying like a good support AE to come in and dial your post, and help you sort out like all of those machine transfer things. And so if you're making $1 million investment, tacking on another 50 grand or something, I made that number up, but to just have somebody like make the rest of those problems go away seems pretty reasonable, right?
Yeah.
And so then it really just comes down to like, is that, do the numbers work on that $1 million investment? And we don't need to dig into like, how many jobs you think you could get on that or anything. People can do their own math on the payment versus revenue stuff. What I want to press on is like, why automation, like there's this huge activation energy for automation, right?
Yeah. Actually, I do have one point on the payment thing.
Oh yeah, go for it.
Which I think people often overlook, which is like, let's say you have a machine let's say it's a commodity machine, like a basic brother, and it costs $2,000 a month or something. I think the math people often do in their heads is, well, yeah, I can bring in, $2,000 a month of work on that machine. Easy, whatever. And they're like, yeah, I need a little bit for material and I need a little bit to pay myself. What people don't often think about is that the payment for that machine needs to come out of your profit. So, and then you have to have profit left over. So that means if you're running 15% profit total, like gross profit margin in your shop, I'm terrible at math in my head, and you want to take out half of that profit to cover that $2,000 a month payment, what does that number be?
$30,000 a month.
Yeah. So that machine's got to bring in 30K a month. So when you scale that to a machine that, let's say, costs 15 grand a month to service the debt.
I hope I did that math right.
Sounds about right.
7%. Yeah, it's about right. Yeah.
Yeah. When you scale that, that starts to be mucho bucks. So
Right.
anyway, just a note to people who are doing the math is like, it's not like, oh, this machine costs $2,000. I need to make $5,000 or $10,000 a month on it. I need to make a significant amount of money on that machine for it to actually be paying for itself and overhead and and still making a profit.
Right. Because it's not just electricity, but it's the tooling costs, the stock costs, fixturing, all of that stuff. Yeah.
It's all of it. Yeah. Anyway.
So that is actually a really critical point that I had never thought about because I don't have to run a shop. Yeah. So, or at least not a profitable shop, I should say. The shop for Toolpath is just a cost center, but it's an R&D requirement for us to produce good CAM automation.
Absolutely.
Yeah. Okay. So that's actually a really important point as people think about automation. And so it's like, if you have to bring in $30,000 a month in revenue to cover your $2,000 machine, which honestly, that sounds like a scary number. When you look at your current jobs, like, is there more jobs you could take? Could you lower your quoting? Those are the things that go through my head. Like, could you offer a better, more competitive price to increase your win rate? Do you feel like you're turning away $30,000 a month or even $15,000 a month? Maybe you're willing to like eat the cost of some of that machine while you grow into it or something.
Yeah.
Or is like the other side of that equation is like you've said that the M300 is by far your most profitable machine.
Yeah.
And so is adding that capability going to give you the opportunity to bring in higher value work, more quantities of work, go after jobs you would normally turn down, that kind of thing?
Is that a question? I would say
no, I'm mostly just
Yeah.
go ahead. Mostly just thinking through your insight there. Yeah.
Yeah, I don't have hard numbers on that, but even just this little count that I did of like the number of jobs that we ran across that machine versus the other machines, I think it is by far, and the value of those particular part numbers as well. I think it's by far the most profitable machine. And yes, we are turning away work. I'm not sure at this very moment if it's a full another 30K a month of work, but I think that's not a stretch at all. So
Right.
Also that machine's more than $2,000 a month if you're just servicing basic debt, but
Right.
but not like orders of magnitude more. It's like double or something, not quite
Yeah.
double.
Sure.
So the short answer is yeah, we are turning away work, and it's always the work that we're turning away is the most profitable work that comes across our desk. So that's what's hard to
And you
swallow.
don't feel like a robot would let you say yes to that work. It doesn't emotionally feel that way.
It doesn't emotionally feel some of it for sure. And
Okay.
like, so we get some of these parts. It's like, yes, this is a complicated part, but it's small. It's aluminum. We're going to make 6 of them. And the first one's going to take us half a day to get a good part. And then, yeah, I would love to run these into the night. And that's kind of actually how I've been proceeding up until like about a month ago in my thought process. Cause we're stalled in implementing a part loading robot on our R450. And my thought had been, once we finish this and get it rolling and we've familiarized ourselves with the platform, we'll buy another one and we'll do a little home bake pallet loading solution for our M300 that'll just like, whatever, have 5 pallets and it'll be that thing, which is like at the end of a day, if there's more of a part to run that we're comfortable running, or midday too, because like it's great to free people up, but that we would run those parts when available. But that's like a $50,000 solution to buy a robot, or maybe 75 to buy a robot and like home bake it, versus double that if you're paying for an off the shelf solution, double or more depending on who you're talking to. Anyway, I forgot how I got on that tangent, but
Well, it's double the cost, but
yeah.
maybe less than half the time to implement.
Oh, more, we were definitely less than half the time. No, it's absolutely worth it, I think. But the question becomes like, is it still worth it if we only capitalize on it for 10 to 20% of the jobs that we run through the shop?
Right. Yeah, that's tricky. So let's dig in a little bit there. Because in my head, and I am implementing the most basic automation. I'm working on a gimbal spindle gripper system
Yeah.
to make swag. And so for me, when I think about implementing automation, and I do want to make an interesting note here that I'm trying to convince you to buy a robot while you've already bought a robot. um, and sort of, it sounds like struggled to get it up and running.
Honestly, the struggle has just been time. Like we're at the point where everything is ready. We just need a break on the machine to actually implement, like it's wired to the machine. All the pneumatics are connected to the machine. And we literally just haven't been able to like take a day and be like to set our points in the machine and test pick and place and stuff.
Yeah.
So it's
I think you and Uriel often make the quote, you'll have time for improvements when you are dead or out of business, right?
yeah, exactly.
And I think about that a lot. So in that situation, I would say make the time.
Yeah, no, we're getting there. We had one of our customers who's also a good friend recently launched a product with not enough inventory, and we've been going hard trying to help him fix that mistake.
Got it. Yeah.
Yeah.
Okay. So, from a mental exercise, as I ramp up to automation, the actual automation part always feels like the most scary to me. Like what happens when you're not there and the machine is running and you break a tool or a part is misloaded.
Yeah.
I very often hear like automation is the fastest way to make a bunch of scrap ever invented. Right.
Sure. Yeah.
Alternatively, I've heard like automation is a process that automatically finds every single weakness in your manufacturing process.
Yeah.
Right. And so if you want to know what those are, just run automation and it will tell you.
Yeah. One thing I always found interesting about automation is the failure modes. We focus so much on the value add process, right? We focus so much on like what happens when the stock is here and what happens, or even like what happens when the stock is misloaded. And we completely forget to think about like what happens when there's no stock. Like do the jaws close to a point now where you just rip through them with your tools? Or does the robot crash now because its fingers are in the wrong place that you didn't expect them to be?
Right.
And there's so many of those accessory things that are like outside of the lane of like what we're imagining the process to be, that are failure modes, that are like tertiary failure modes that we're always like, oh, wow, didn't think of that one.
So when I think about ramping up toward automation, I'm like, okay, how do we simulate that process? And so I have encouraged you and other people to pretend you're a robot, right? Like if you want to know if automation is going to work, have somebody prove out a job, and then you stay an evening when nobody else is in the shop and blindly run 5 pallets of that part and then leave them on their desk for them to look at in the morning, right? Like, and like no matter what happens, you have to commit to it, right? Like if a tool breaks, you got to keep going. If the process, you know what I mean? And it sounds scary to do, but it's like almost free, except for your time, which is not free, but almost free. And I feel like that is a way to sort of like chase the scariness of automation away. And also in your case to really test like, okay, if you committed to like finding your automatable jobs for say a week, right?
Yeah.
And then everybody, just making this up, everybody agreed to take a late shift one night and be the robot. How would that affect things in the shop, right? Like how would that incremental change opening that up? Could you do more prove outs? Would the stress levels in the shop go down to the point that tool changeovers didn't feel like they were so crazy anymore? Like they just didn't feel, because like right now your tool changeover has to happen quick because it's stopping you from getting work done. But if like your day was a little bit more open, then maybe the tool changeovers wouldn't be the problem. That's just made up, but would you try a human automation sort of test run?
Yeah, absolutely. I mean, like the idea sounds great. I think the challenge I find, it would have to be me, I think.
Right. Yeah.
Pretty much. Well, that's not entirely true, but most, and I mentioned this on another podcast, but like I've always had a very, let's see how to say this. I came from a family and background where like the idea of like pursuing making money was sort of like base. And this is something I've had to grow out of in becoming an adult. But um, like pursuing things for passion and lifestyle was very much like vaulted, and but pursuing things just for money was like, ugh, don't do that. Um, in any case, where that has kind of led me is to I have never approached this business from a standpoint of like, I'm here to make $1 million personally and like, get out rich. I was like, I want to have a successful business and I want to lead a good life. What that has meant is that I really try and prioritize people's life outside of work. And we, so people do come and work overtime and people hustle when we need to, but I try really hard to respect people's need for their evenings and time off and whatnot. And so I typically don't ask for that. But that's an aside. So it would probably have to be me. There's maybe one person who likes that, but
I will come be your robot for a 1 or 2 nights.
okay.
Yeah.
There we go.
And that's not a joke. I will come do that for you. But fair warning, I will be a robot, right?
Yeah.
Like I will put the pallets in the machine, and unless it's like catastrophically awful, like
Yeah.
just gonna keep running it.
Yeah.
So, and I won't answer my phone if you want to know how it's going, because a robot cannot do that. So you got to set up a webcam if you want to know how it's going.
Fair.
Yeah. No, I think it's a fair point. Although to that end, right, I think this is another place where automation sort of fundamentally changes the game.
Yeah.
Because you have said you have somebody who's just kind of standing there during the day loading parts, and that person doing that role may change, right? Like,
Yeah.
Which is great. I applaud you for having a shop where you don't sort of pigeonhole people into that mechanical task.
Yeah.
But investing in automation would be an opportunity for that one person to not be doing that at all.
Yeah.
Potentially.
Yeah, absolutely. That's why we bought the robot for the 450, is because we were often having a scenario where like 3 other machines would be running high value, low quantity work. And so that's basically like setups, more or less. And then a couple changeovers or a couple, part flips or whatever. And then there would be the R450 just kind of like grinding on like 10, 20 minute cycles that you had to be at the machine every 10 or 20 minutes. And like that was enough of an interruption for one person that they couldn't really engage in anything else, but they weren't really busy tending the rest of the machines. And it was kind of like, this is a bit stupid at this point to have like this one task that keeps somebody busy enough that they're incapable of doing anything more value add in the business. So that's why we initially bought the robot for the R450, even though it's like probably our lowest revenue machine, was to be able to free somebody up to do more interesting work. Yeah.
So that circles back to robot versus new spindle. And I think another way to think about this is that a robot reduces the amount of work you have to do, and an extra spindle increases the amount of work you have to do. And both of them are in theory increasing your efficiency or your revenue, your profit margin, however you want to think about it.
Yeah. Throughput at the very least, hopefully.
Right. Your throughput. Yeah. So in that regard, in the pursuit of like a good job where it's totally possible for people to go home at night, I think the robot wins in that scenario. It may be like a short-term investment, and there may be some time where you're like, look, I don't normally want to ask for overtime. I'm absolutely not trying to tell you how to run your business, but just from like a human perspective, like, hey, could we invest some overtime to free ourselves up on the other side of this equation? Because I do think an underappreciated point of lean, although I'm sure that you appreciate it given how heavily you focus on it, but for me, it sometimes gets lost until I take the time to do that lean improvement, is not just the time savings of lean, but the mental load reduction.
Yeah, 100%.
And so when I've found those improvements, sometimes they don't even save time, but they reduce mental load.
Yeah.
That is the most valuable thing for me.
Yeah. Often I find that they increase in station time, like for a single task. But the overall start to finish time of the process goes
The
down.
throughput goes down. But even if the throughput went incrementally up, is my
Yeah.
point. But my mental load went down. So for me, a really simple example of that is I spent like way too much time coming up with a tool tag system, and I actually still want to revise it again. But the entire point of this tool tag system was that, and this is a little bit unique to our R&D shop, was that I needed the tool tags, the tool boxes, the tool bins to move with the tag.
Yeah.
Because like I came into the shop one day and I needed a 82-degree countersink bit, and I knew we had one, but then I went to the machine and there was an 82 and a 90 and they were the same diameter. And like, I don't have a comparator. And like 45 minutes later, I'm like looking, cause I was like, fine, I'll just take a new one out of the bin. And then we didn't have one anyway. Like that whole process made me so angry. And I realized that like the mental load, and in my shop that happens because we have multiple people coming in and doing like a project, and we don't have like a really rigorous like break down your tools and put them back in the bin kind of process.
Mm-hmm.
And so I was like, you know what, like we could implement ever more draconian process, or I could just make the toolbox travel with the tag.
Yeah.
And that seemed to work. It was very low effort when you're building up the tool to like rubber band the tag, the bin to the tag. And then, now there's never any question. And so that reduction of mental load made it so I went from like hating building up tools to being totally fine with it. And if a tool gets left in the machine, it doesn't like freak me out anymore.
Yeah.
So in the context of automation, I would say a robot would potentially increase your ability to offer like a really great working environment to your employees.
Yeah.
And a new spindle might do the opposite, might make it harder on everybody.
Mm-hmm. Yeah.
So when I think about like where to invest, if you have that philosophy for your business, then I would say the robot like doubly wins versus the new spindle.
Yeah.
If you could only buy one.
Yeah. Yeah. If you can only buy one. Yeah. The only sticking point for me really is the scenario that I brought up at the very beginning, where we get a run of hard parts in a row that have to go through that machine. And then we become really, let's see. So let's say we quote, backing up a bit. Let's say I have 3 customers reach out to me on the same day, and they each want 5 parts, and all 5 of those parts need to go on the M300. And let's say I quote all of them at 4 weeks as just like a generic lead time. And let's say in this scenario, all 3 of those quotes land, but I only expected one of them to as a job.
Yeah.
And let's say none of those, just for the sake of argument, let's say none of those parts are automatable. Now we have...
Hang on, they were 5 quantity each?
Yeah, 5 quantity each. And I don't know, we'll slap a day number on there that's impossible. Let's say it's 5 days each.
Okay, we're going to circle back to why they're not automatable, but continue.
Yeah. In my gut says they're not automatable.
Yeah.
In that scenario, we have a robot sitting there, and we're having to ask people to do overtime because we don't have any ability to multi-thread or, multi-channel the work through the shop. And so that's the one scenario where I get really anxious about only having one spindle that can handle the work.
Because just to check the math on that and make sure my understanding is correct. In that scenario, you have these jobs, and if there was another spindle, you have a person that could be moving the work through that machine. They're not already doing something else.
Yeah, or we could, move them from something else that was lower priority.
Okay, great. Okay.
Yeah.
So that's just a straight up like capacity limit, right?
Yeah.
Which is sort of only solvable with another spindle. But now let's circle back to what you said. There are 5 parts and they're not automatable.
Yeah.
Why can you not prove out one part and then have the robot run the next 4 at night while you continue making prove outs for the others?
Yeah. So this is a good point, which we haven't touched on yet. I think the limitations there right now are mostly to do with like tolerance guarantee. So we're getting a significant number of parts that have, plus or minus 5/10, not all the features, but, a handful of features, tight profiles, tight positionals. And we don't have systems built into the machine yet that can handle tool wear for turning tools or tool breakage for turning tools. and we don't have macros built into the machine yet that can dial in offsets based on measurements to that. Well, we don't have it at all right now, and I don't know if I would trust, honestly. It would take a bit of work, I think, of testing to get a system that could dial in those tolerances accurately with probing, but I'm sure it's possible. And then the sort of additional factor is sometimes this material, let's use the 4-week lead time example. Sometimes this material only comes from a couple vendors because of the whatever AMS spec, and it's expensive. And sometimes there's additional pre-processing as well. And so we can't really, we usually get a couple spares, but we can't really afford to scrap it because there's no option to go to McMaster and get more material the next day. So those are sort of the limiting issues there.
Let's set aside the can't afford to scrap it. I think that's actually a really, really valid point, but it also contributes to like the fear of automation and circles back to the mental load there.
Yeah.
So I'm going to press pretty hard here. Whether you're getting another spindle or getting a robot, it seems like the key problem that you need to solve is all of those things you just said.
Yeah.
Tool wear, macros, like before, if I was in charge of your shop, before I would sign off on either a robot or a new spindle, I would say that you need more mental capacity in the shop to get all of those issues you just talked about off the mental gymnastics or treadmill, right?
Yeah.
So what's stopping you from solving those problems, either by paying somebody to help or by committing some time to them?
Yeah, stopping right now is just skill level in the shop. Like, I don't think any of us in a reasonable amount of time, any of us who currently work here could tackle that project. And then just not having prioritized it, basically.
But if you're thinking about, I guess here's my point. If you're thinking about making an investment in another spindle or a robot, why not think about investing in some help to solve those other problems first?
Yeah, this is not an excuse or a good reason. I think the actual reason is just that we have a process that we're familiar with, that we make parts with every day. And so rinsing and repeating it feels very simple. But it's, it is a sideways step, I think. Like it gains us capacity, but not in a it's just a 1-to-1, basically, capacity gain. It's doesn't have leverage.
Sort of, that's true, but that's like the lean philosophy would argue that like making those the third, the second, third, fourth, fifth version of that part be like, okay, it's proved out. Now it can just run. Like getting that off your plate so that somebody doesn't have to sit there and babysit the machine would have outsized impacts on.
Oh, absolutely.
Yeah.
That's what I'm saying. I'm saying, like, if we just bought another spindle, it's familiar, but it's not like a step function. It's just like we get one more, we can do one more worth of stuff.
Right. Yeah. So, again, I'll remind everybody here because I just don't want everybody to think that I'm like attacking your business here. I'm purposely being the antagonist, but
it's a great conversation to have.
But like as a lean, like somebody who really believes in lean and like studies it and talks about it on your own podcast every week, I'll press for you to think carefully about why that's not where your brain goes to, in terms of like how to take the next steps for your shop.
Yeah. I think it's like, just to answer, like it is fundamentally because most of that is like programmer work, and I like legit programmer, not CNC programming. And that's not somewhere where I'm comfortable.
But you could pay for help there.
I could. Yeah.
And I think adding another spindle increases the workload in the shop. My fear would be, and I'm sure that you guys have the talent to make this not happen, but it increases stress level. When I'm tending to machines, like my fear is that your scrap rate on that expensive material would go up, or right, because there's just, now you're trying to run, even though you're good at the M300, like it's just a lot more going on. And now there's two jobs that are very complex, and the sort of second order effects of like tool wear and things that you don't really think that you things you don't realize that you're putting a lot of mental energy into monitoring
Yeah.
start to slip when you have to do it across two machines.
Yeah.
And so you might find that like you buy that second machine and the process is just not strong enough to support multi-threading.
Hmm.
You know your shop much better, so you have to know whether you're confident to get over that hump. But that, when I think about automation and prepping for automation or another spindle, that's where my brain goes to, right?
Yeah.
Is like, okay, let's like, it's, if I was to describe it a little graphically, I would say what I'm hearing from you is that you have like optimized your process. You've created a pretty tall peak that you're sitting on top of.
Uh-huh.
But if you fall off that peak, it's a pretty steep fall.
Yeah.
The process, it could be a little brittle, right? And you want to
Yeah.
turn that into more of a plateau,
Yeah.
bring the edges of the bell curve up, maybe even at the cost of sacrificing a little bit of the top of that peak.
Hmm.
Get that plateau, and then you can start ramping capacity, whether that's another spindle or a robot.
Yeah. Yeah, absolutely. Yeah, I think part of it is just a lack of vision as well, that like I personally have not seen many folks implement these kinds of systems effectively on the brother machines outside of high production environments,
Mm-hmm. Mm-hmm.
right? Like I know that people are doing it in high production environments. I have not seen personally, I probably there's someone out there doing it, but I have not seen many folks do it in a very high mix environment where it's like a seamless flow from cam and doesn't require a bunch of additional tweaking to get it to function, where we could, do effective in-process measurements and offsets for this sort of complexity of work and have it, not just add more scrap, basically.
Well, I'll say, in terms of the in-process stuff, that is just a sort of get help with it problem.
Yeah.
I mean, the Bloom probes, are you running Bloom or Renishaw on your machines?
Oh, we have a mix of the actual hardware, but it's all the Bloom software,
Okay.
Bloom macros. Yeah.
I know the Bloom probes are very, very accurate, and you can get the OMP 400s are very, very accurate. So as long as
Yeah.
those are properly maintained, if you have the macros for in-process inspection and comping, you should be able to trust those. Now, I mean, look, I'm not an expert machinist. I just machined a part to within a 5 thou. It was plus or minus 2 thou was the tolerance I gave myself, but it was like 7 thou range, and that I was very stressed about that. So, and I didn't use a probe to comp in and measure those because I don't have that setup dialed in on my Speedio either.
Uh-huh.
But those are like absolutely, again, just solvable problems to just have an AE come in and help you get that dialed.
Yeah.
And then it's like part of your process, right? And that would help reduce the work and increase the throughput of your shop without any additional capital expenditure.
Yeah, absolutely.
So again, I'll press and say, like, consider carefully why you don't take those steps. And if let's say hypothetically the Speedio is somehow a limiting factor there, then as you start to think about what your next machine should be, like, yes, $1 million machine is expensive, but if it's a machine that unlocks that capability without having to worry about it, then right, like 6 M300s, when you have a process that would require you to bring on more and more people, and like, how would you get parts through that versus one Hermle? If the Hermle is more automated, like, that's the better choice.
Yeah, I mean, that has honestly been one of the big things that makes me want to just go and buy the Hermle, is that a lot of that stuff is pretty baked in to the machines as they come from the factory. And it's like, well, I could put in a bunch of work and hire an AE and dedicate a bunch of time to testing and refining this process, or we could just buy this other thing. But it is a lot of money. Yeah.
So I think the fundamental question you have to ask yourself is, like, what's scale look like for your business, right? What, like, if you wanted to end up with 6 M300s with automation on top of them, and you thought you could support work for that size of a shop, then investing the money to sort of reduce the capital expenditure makes sense. But let's say that like one Hermle with a pallet system would be enough capacity for you to grow the shop to where you're comfortable with it. Or at least your first step, and maybe like ultimately 2 of those machines would be where you'd end up or something, but not more than 2, hypothetically. I think those are trades you have to play in your head in terms of like how much capital you want to expend now versus later.
Yeah. Yeah, absolutely.
Um,
Yeah. And then the other thing we haven't really talked about is programming capacity, which is
right.
like right on the edge of being a bottleneck in our shop.
Hmm.
Yeah. We've kind of managed to like get out of that point where it was the constant bottleneck. But if we add automation and throughput, that problem will probably come back.
Sure. Automation is an automatic process for finding every bottleneck in your shop.
Yeah.
Um, but how many times are you out on the floor loading parts or checking?
Me personally,
Yeah. Hmm.
not super often.
Not super often. Okay. So what I was getting at is if you reduce the mental load in the shop, would that increase the availability for programming or even increase the availability to train somebody else in the shop to handle programming?
Yeah, potentially. Probably not myself personally, because like that's not where I am tied up. But yeah, that's sort of the hope.
Yeah. Okay. Before we should talk about like the programming bottleneck a little bit.
Hmm.
But before we do that, let's talk about what a tool changeover looks like for you, because you've brought that up as a bottleneck a few times. And
Yeah,
obviously, the tool capacity in the Speedio is a problem.
yeah,
You have a pretty cool tooling system, but
y-
uh, I don't want to get into like all the details of your tooling numbering and everything, although I
yeah,
think
yeah,
that's really insightful. Let me just ask a couple really basic questions.
yeah.
How often are you building a tool for a job?
Um, every job.
Every job gets a tool built.
I think
Like
so. Honestly, I
many
don't.
tools or one tool?
It's hard to say. I don't know if I have good information here. We keep a fair number of tools built. They are somewhat random as to what is built. It tends to be kind of what has been pulled out of machines. We
Hmm.
won't we won't necessarily break a tool down out of a holder until we need that holder again.
Okay.
So it does, I think, in some sense, like quote unquote self-optimize towards like what we use. But I would say that every job is they call it a bingo on the floor when you do a setup and you don't need to change over any tools.
Okay.
That that is rare. So every job you're changing at least a few tools, pretty much
Changing, when you say changing into the machine, or do you mean building a new tool in a holder?
into the machine.
Okay.
And I think the number of times that you're building really just varies from job to job and what has been run prior, kind of like what the work mix has been in the shop up to
Do
that
you
point.
think the bottleneck is building the tools or swapping them into the machine?
Building is not a bottleneck because it happens offline. It's like a secondary process
Okay.
that we build into a buffer that feeds the floor if everything's running well. And the actual time to change over tools is not significant. We've refined that process pretty well. So it's like, I don't know, 30 seconds to a minute per tool, including touching it off and being ready to roll. The primary concern I have there is more that it's still a potential error vector
Hmm.
in that our our tool our tool like our setup sheet that defines the tool is fully defined for everything that needs to be done for that tool to function. However, people are still fallible, and occasionally people, not on purpose, but will cut corners, will just be like, this is a number 271. Oh, it's got the right stick out, but miss the fact that it has the wrong holder. And so in the instance of running automated, I don't think we're quite at a level yet where I would feel comfortable people just swapping in the tools, touching it off, and hitting cycle start and leaving. I think you'd still want to be present for one cycle potentially to make sure
Yeah.
nothing hit. As I say all of this, obviously there's low hanging fruit of work to be done there to how to mitigate that risk and make the process more reliable. But it still is like a human building up human building up a tool, or working towards standardizing the tool library to the point where there is no alternatives. But as I've said, we have found that to be what's the word? We've
Like
just found
unrealistic. Yeah.
unrealistic. Yeah.
Yeah. But, but I bet, um, like, frankly, what you just walked through of like, what if a person put the wrong holder in, screams for you just need more holders, and like leave more tools built up. And it's probably, there's always like one tool that needs to get built, or like, but like, I bet if you did a detailed study of your job, and I've actually talked to several people about this, you would find that you probably need to add like 20 permanently built tools or some number. I made that number up, but like, right. And that you could come up with like an offline tool presetter or an optical system that would validate that the tool was built as expected, including the holder and everything. And then it's built and it doesn't get broken down. Right. And so that almost completely mitigates the risk. I would encourage you to consider something like that. Like holders just aren't that expensive anymore. You're not talking about a huge outlay. And so, especially if you do it incrementally, right? And so there again is like the mental load of like, okay, you know, if we don't have to worry about people building the tool wrong and they literally can just be loaded in the machine, or even better, like, I mean, there are systems you can buy where they get loaded with like their offset already programmed and stuff. You know, if you really wanted to stick to these more commodity machines, then maybe that's part of the investment, is investing in a higher tech tooling crib.
Which effectively is what we would have to be doing if we bought the higher end machine with a tool matrix or a higher capacity tool carousel anyways, because we'd be predefining it in the machine and we'd be forced to create a de facto standardized tool set.
So this came up in some other contexts where people, it was a very, very large shop with many, many machines. And so like this, they were asking if I could come up with, kind of similar to what you've asked for before, could I come up with a program that would help them know which tools were in which machines and like dispatch the right part to the right job? And I told them, in theory, yes, I could. In practice, this is a terrible idea. What you should do is, in their case, you should put, because I just said like increase, like take all of your extra tools and put them in every machine. And it was some big number, like $5 million it would have cost them to buy that many tools. And they said, we could do it, but we're not sure we want to spend $5 million to have these tools never be used. So I said, all right, don't do that. Put all of the tools in 2 machines. And any job that doesn't fit in the sort of existing standard library goes and runs on those machines. And when those 2 get overloaded, then you figure out which tools you need to add to all the other machines. So rather than trying to like...
These are higher capacity tool machines?
Yeah, very high capacity. In their case, hundreds of tools. But I guess my point to them was like, they were trying to use software to fix a non-standardization problem. And it was like to save capital outlay. And I was like, I don't think this will work. Like we could build this system, but I don't think it'll actually do what you need it to do. You're better off just buying the tools. And here's a lower capital way to do it that gets you 95% of the benefit. And in your case, I would say like, you know, if you can reasonably stock on the shelf a few extra holders. I don't know if you keep everything in ER. Obviously, if you're putting everything in like PG, it starts to get pricey real quick. But
we have a mix of we have a significant mix, which is maybe part of the issue there.
But you could also, even there, build up a process where like something gets put in a lower cost holder to start with, and only like over time migrates to a higher cost holder when it's needed, those kinds of things. There are ways you could try to mitigate that. But if one of your major concerns is tool changeover and there's like a risk factor of the tool not getting built properly, again, there, I would say like, even without investing in anything else, you could improve the efficiency of your shop by sort of mitigating that.
And we've, you know, as a group here in the shop, we've talked about this at length and we've attempted different versions. So not to dive too deep into the tool library, our tool system, but when we started this whole system, we were like, these are going to be standard tools that were always built up. And then we were going to have like a medium standard version that was like one of each built up. So things that we didn't anticipate needing in multiple machines at once. And then everything else was going to be non-standard. And what we've found is that we just don't have a really good way to pull, I think, that data out of our actual process of what those tools need to be that we genuinely use on a routine basis, but maybe don't seem like we use on a routine basis. And so we've attempted this, but we don't actually know what we need to make our standards. And that's been the challenge.
I mean, there are some, like, I think these are lean techniques like yellow tag, red tag, right? Like you could play some games there. You just have to be willing to invest in holders.
Yeah.
But you build a tool and then put a tag on it, and then, it stays yellow until the 5th time you've used it or something. Like somebody literally like puts a little, what are they called? Crosshatch? I don't, like line.
Oh yeah, tally.
Tally, thank you. Yeah, puts a tally mark on it or a sticker on it. And, you can change the color of the tag like every 6 months. So you go yellow, red, green, whatever. And then if tools don't have enough tally marks, then okay, I didn't use this that often. That does raise a really interesting point. And I will pull a small tie into Toolpath, not because it's a commercial for Toolpath, but because I think it's an interesting aside. One of the challenges that I have seen when people have a lot of tools in their library, like the purpose of a narrow standard library is so that you can keep it in your head.
Yeah.
Okay, I know what tools are available. And then as you start to like build a tool, if there's more than 1 or 2 people programming and you don't have the entire tool library in your head, or even if you try, but you have, say, 70 tools built up or 80 tools, it's really hard to know if you have the tool you need. And I'm guessing you have a way to deal with this in your shop, but even there.
Yeah, we have a strict Kanban system for our tool management, and we, over the course of, 4 or 5 months, because it would have been a huge amount of money to do it all in one day, we just built out so that we have our minimum quantity of everything. And then
but when you're programming a part, like, how do you know, this like super deep pocket that it doesn't fit my standard tools? How do you know if you have an end mill to work for that feature or not?
It's in our CAM library.
But do you sit there and scroll your entire library? Like,
oh no, I mean, you just use filters or whatever. You can filter.
So you'll filter by like
and,
flute length and reach and all of that.
Yeah.
This is another place.
Definitely not pulling from my personal memory. For tools. Yeah.
So that's interesting. I honestly have never heard of anybody else doing that by like filtering by what you need. That's great, but that is a mental load. And as the tool library gets bigger, it's great that you guys maintain such a detailed library. One of the things that CAM automation can bring is just tell you like, oh, you have a tool for this. Here's the tool.
Yeah.
And I find that to be unlocking for a lot of shops who feel like a very large tool library is overwhelming. Because you can filter through it, but even when you filter through it, you maybe don't know if the holder is going to reach and all of those things.
Sure.
And then also as you try to scale, if you need 2 or 3 programmers, obviously maintaining a consistent library becomes the challenge there, but getting everybody to know what tools are available can be a challenge. Using the filters is honestly an obviously great idea that I had never thought about, but automation there is another place that can reduce the mental load.
Yeah, absolutely.
Yeah.
It's a trick, and our system is not perfect by any stretch, but to address some of these issues, we basically decided like anything that's in the library, we have to have in stock. And then we have one library. Well, that's not true. We have a turning library, which is like the redheaded stepchild of our shop. But for milling and drilling and tapping, we have a single library that's like the single point of truth that represents our physical tool storage. And that's what everything gets pulled from. So, which is, I think, makes some people twitch a little bit and is not the way most people handle it. And it does force some of these other issues where we're pulling from this standard tool, but then we're modifying a stick out or a holder, and that passes through to a setup sheet and has to be, the setup person has to pay very close attention to that to make sure that it will work in this situation.
So I would encourage you to keep an eye out for the Haas Black Friday sale, order a big box of holders and modify that process so that if you need a different reach, that should get a new tool number. And build up a new one.
Yeah.
Yeah. I think out of everything we've talked about, I actually think that has the most possibility of lowering the load in your shop would be like just more holders and just like they're built and come up with
Yeah.
some kind of a system like a tally system or something where you can like decide to take tools out of circulation. And then when you do that, they get pulled out of the library at the same time kind of thing.
Hmm.
Or put in like a secondary library so that you can filter them or something. You'll come up with something.
Yeah.
But the thing I like about that is all of these things are issues that you know about already that would prevent you from being successful with automation.
Uh-huh.
And I think it's too easy to pretend that they wouldn't also prevent you from being successful with another spindle.
Yeah, that's fair.
And so that was at the core, and just for the audience, like the kernel of this podcast was I heard your statement on with intolerance about you wanted a new spindle before a robot. I think I texted you like, "Hey, I want to fight you on this," because I spend way too much time thinking about the theory of it, and I appreciate the chance to like talk to somebody who has to like deal with it in practice.
Yeah.
But I think far too often the assumption is that automation is hard because all of these things that are weak in my process won't survive automation. So I'll just buy another spindle. When the reality is like another spindle like amplifies those problems too. You just work harder to get over them.
Uh-huh. Yeah.
And if we are going to be successful as an industry, we can basically almost never choose to work harder.
Yeah, no, 100%. It's kind of a wild time to be in this industry because like we are being somewhat successful, like our shop and many of the people that you and I both know. But it's a little bit of a false, none of us are working in like what people think of, Joe on the street, what he thinks of when he thinks of manufacturing. None of us are doing that.
Right.
And currently in this country, as far as, maybe outside of automotive and a couple other like very specific cases, the manufacturing industry is not competitive in that realm.
For mass production. Yeah.
For mass production.
Even sometimes for prototypes. Yeah.
Yeah. And so I do sort of feel like we're on borrowed time pretty often. I'm like, this is not long-term sustainable. My business as it currently exists, it is something we absolutely have to tackle.
So I think you're agreeing with me that you shouldn't choose to work harder, even if another spindle would sort of relieve a bottleneck.
Yeah.
It sounds like you're not ready for that yet.
Yeah. I mean, the other spindle comment and thought is strictly for that scenario that I've brought up where I feel like we don't have the skills or ability to get through a group of parts that are all due within the same amount of time, making use of automation.
Yeah.
And feeling like leveling up our skill level sounds really hard. It feels hard, when we're already like kind of at our limit.
Yeah.
A lot of days.
But you should just buy the help you need there, I think.
Yeah, I think you're right. Yeah, I agree.
So it's interesting because where I sit, I sit in a very privileged position, sort of capability wise. Like writing a macro just doesn't freak me out, right? Like there's almost no level of complexity in a macro that freaks me out. It's just a question of like whether I have the time to sit down and do it.
Yeah.
I literally rewrote all the probing macros from scratch for fun. Well, for fun in quotes, because I wanted to on my side. I rewrote the probing macros on the Speedio, or the tool setting macro on the Speedio because I wanted to. But not like, that's because I'm a software developer. So like macro programming comes easy to me. That's not a skill that most machinists have.
Yeah. I've done some work enough to familiarize myself with it, but it's not at the level of comfort of anything else I do in the shop. So it is one of those things where it's like, okay, no one talked to me for the afternoon. I'm going into this land. And most days for me personally are not days where that's possible.
There are some forms of automation. I'll put spindle gripping in this category where like a deep enough familiarity with the macros is actually just straight up required to run it.
Yeah, absolutely. Yeah.
But I feel like there's a bit of a misconception that like, oh, if I want to do automation, I need probing macros and I need tool setting macros and I need to really be good at this stuff. I actually think that's false. You're running macros on your machine almost all the time. If you're probing by hand, you're running a macro.
Yeah.
I can almost guarantee that you do not know how those blue macros work.
I went through and tried to comment it out at one point, and I got a decent way through, but I was like, there's still stuff in here that I don't know what that does.
Okay. You did more than 99.9% of people, including me. Like, I took one look at those macros and like, I would just write it myself before I tried to understand whatever crap is in here. And some of that's by design. They have like automated systems that generate the macros and the systems are more readable, but like for them, outputting readable code is just not an important part.
Yeah.
But my point is that you're running macros and doing things in your control all the time that you do not have a deep understanding of, that
Absolutely.
some application engineer just sort of made work for you. There's definitely a perception, and I feel it too, of like, oh, I'm bringing this new robot in, or I'm bringing this automation system in, and so this is going to require me to get really good at all this macro stuff. Honestly, I'm not sure that that's true. Like, you can pay for the support you need, and they'll come in and make it work, and then it'll just be like probing is for you now.
Yeah.
So, and that's a cautionary or sort of a thought process for everybody out there. But, you know, we're willing to spend a bunch of money to get another spindle, but I think we should be willing to spend a bunch of money to get more automation. Even like in your case, there's frankly automation available to you that doesn't require new hardware in the shop. The tool library automation, probing automation, tool setting automation, things like that.
Yeah.
And all of those are good prerequisites to actually buying more hardware.
Yeah.
But they don't feel like it is the problem.
Right. Yeah, absolutely. And I'm aware of this and I still do it constantly. I forget where we left it. And I'm going to have to wrap up in a little bit here because people are going to show up and it's going to get loud.
Mm-hmm.
But approaching this, figuring out, like, there's the tally thing as one that's very simple way to figure out what our standard tools are.
Mm-hmm.
Do you think there's a way of like going back through, 6 months of posted programming and just and have it tally basically how many times each tool was called?
Absolutely. That's doable. Yeah.
Yeah.
I'll take that on as a side project with you.
I feel like that would be the failure mode of the tally of like physical tallying on tags are many and
I should specify for the listening audience. I know it from listening to your other podcasts. I know enough about your tool library to know that every tool gets a unique number.
Yeah.
And so for you, it's possible because every tool has a unique number that's consistent and traceable. For a generic person, like in my shop, my core tools are like 1 through 10, and then every other number is, let's call it random after that. So I would end up having to like compare the geometry and metadata of the tool, and then it would get a lot more brittle. But because I can trust that tool 117 is always tool 117, it should be very, very possible to like go through an old series of in fact, there may be something in pre-tool already that could just do it.
Oh, interesting.
Or almost do it. So yeah, we can talk about that offline.
Okay, that would be cool. Yeah, that's like just thinking through the failure modes of like tallying. It's like, does the tally stay with coolant? Is there good conformance to the process? Like, does every person remember to do this other additional non-critical step to an already somewhat complex process every single time they build a tool or put it in a machine?
Yeah. I mean, pulling it out of the data would be way better, but also the tally system doesn't really have to be perfect to be useful.
That's true. It just needs to get within a mile, kind of.
Yeah. Right. So, okay. Well, thank you so much. Let's, where do people find you online?
You can find me on Instagram at Lichen_MFG. That's LICHEN_MFG. LichenPrecision.com, or I believe also LichenMFmanufacturing.com. And that's pretty it. I got a LinkedIn profile, but I don't really post there. And
definitely people should check out the Incremental podcast.
Oh yeah. An Incremental podcast that my friend Ariel and I do every week, where we deep nerd on, we try and keep it not specifically machine shop related, but we both run machine shops. So there tends to be a fair amount of that.
I find your podcast to be one of the most sort of thought provoking for me. So thanks for coming to do a deep dive here on this with me today.
Yeah, absolutely. Thanks for having me.
We'll have to do a follow-up episode on your tool libraries amp, and when I come, make a bunch of scrap as a robot in your shop.
Okay. That sounds good.
All right. Thanks
Cool.
so much.